Hello. In this video, I'm going to be covering the concepts of variance and standard deviation. And these two concepts fall under an umbrella we call summary statistics, which are just values that tell us information about a data set in a very brief way, so that we don't have to look at every single data point individually. They summarize the data set. So the mean or the average of a data set is also another summary statistic, and what that shows us is kind of where the center of the data set is. Whereas the two concepts we're going to be learning today, variance and standard deviation, explore how spread out the data points are. So the way we're going to do this is just to do a quick question to kind of explore everything with a bit more context. So the question says, in a shot put competition, 4 students each throw a ball. The balls land 1 meter, 3 meters, 4 meters, and 5 meters away. What is the variance and standard deviation of this data set? So the first thing I'm going to do is just draw out a sketch of this question. So 0, 1, 2, 3, 4, 5. So the students start at 0 meters away and they each throw the ball. The first one lands 1 meter away, the next one lands 3 meters, 4 meters, then 5 meters. And the question wants us to find the variance and standard deviation. So the first thing we need to do is calculate the mean, because that's required as part of the calculation for variance and standard deviation. So if we remember, the mean, denoted by mu, is simply the sum of each value divided by the number of values. So that would be 1 plus 3 plus 4 plus 5 divided by 4, because there are 4 values. So 1, 2, 3, 4, 5, oh sorry, no 2, 1, 3, 4, 5 divided by 4, I get 3.25 meters. So we have a mean, it's around here. I'm going to denote it by this red line. And it tells us that the average distance that the ball is thrown is 3.25 meters away. So again, the mean tells us, okay, where is the data centered around? But that by itself is good, but it would be nice to also have an idea of how far spread out everything is as well. So one logical way we could do that is to find the average distance each data point is away from the mean. And what I mean by that is, okay, this first data point, it's this distance away, this next data point is this distance away, this third one is this distance away, and the fourth one is this distance away. So if I just average out these distances, that would be a pretty good representation of how spread out the data points are. So how would I denote that? I would do this. The sum of each value, take away the mean, divided by n. And what I'm doing here is I'm just simply finding the distance, which is, one point, and take away the other. I'm summing them all up, and then I'm dividing by n. But we run into a problem, which is that not all of these distances are going to be positive, because some values of x are higher than our mean, which will give us a positive distance, but will give us a positive value, but some of these values are lower than the mean, which will instead give us a negative value. So these positives and negatives, they don't really play together too well. So what I'm going to do is I'm just going to square everything. I'm going to take the squared distance from the mean. So this first point, I do the mean, I do the value, take away the mean, I square it. Same thing with the next one, value, take away the mean, square it. And when I repeat this, I get the sum of the squared distances from the mean. And when I divide by n, that just kind of takes the average of that. And that's the formula for our variance. So V is equal to the sum of the squared distance away from the mean. So in this case, this would look like, actually I might do it a bit lower down because it takes up quite a bit of space. 1 minus 3.25 squared plus 3 plus minus 3.25 squared plus 4 minus 3.25 squared plus 5 minus 3.25 squared, or divided by 4. And I get 35 on 16, which is 2.1875. And the units for this is meters squared. And that's because we took, again, it's because we took the squared distance away from the mean. But that's not very useful to us because our initial units are in meters, and it's not very intuitive what meters squared means. So instead, what we're going to do is find the standard deviation, which is simply the square root of the variance. And this symbol that is used to denote the population standard deviation is called sigma, lowercase. So I'm going to square root of the variance, which is square root of 2.1875. Which gives us 1.479 meters, and I've rounded it off to 3 decimal places. And that's how you find variance and standard deviation. So again, the mean tells us where the center of the data set is, but our variance and standard deviation tell us how far spread apart all of the data points are, and we do that by finding the squared distances away from the mean, the average of the squared distances away from the mean to find our variance. But because the units are in squared, we just square root that to get our standard deviation.